Hello, math students. Mr. Zacek here. Welcome to Trig Day 1 here. We were talking about right triangles, and we're going to kind of expand our knowledge of right triangles looking at trigonometry, which is the study of how the sides and angles are related in right triangles. Now, the first thing that we need to remember about right triangles is that when we think about right triangles, it's a triangle with a right angle, which of course is a 90-degree angle. So that's how we can tell if we have a right triangle. And in right triangle, we have a hypotenuse and we have legs. Now we're going to use some new terminology here today, and you see it here on our page and on your note sheet. And the first is the hypotenuse. And the hypotenuse is the side across from, I don't think I spelled that right, across from the, I'm going to respell that, from the right angle. Side across from the right angle. And so, in the diagram that we have here with triangle CBA, if we go across from the right angle, the longest side, there is our hypotenuse. Now, no other side in that triangle is ever going to be the hypotenuse. But the other two sides that we have depend on which angle we're talking about. And when you see the word adjacent, the word adjacent is a word that means next to. So an adjacent side is a side that the side that intersects with the angle at the hypotenuse. I don't like that definition a lot, but and the opposite side, the last side that we have, is the side across from the angle. The side across from the angle. So one of the things you're going to hear me say, it does not touch the angle when we're talking about the opposite, okay? And again, the thing with these two is they depend on which angle. They're going to change based off of which angle you're talking about. So, in our particular diagram that we have here, as we look at this angle, the first one that we see here is this angle A. Okay, well, we've already identified our hypotenuse. Now, adjacent. So when you draw your little thing here, what two sides does it touch? Well, it's going to touch the hypotenuse, and it's going to touch the adjacent side. And then across from the angle is the opposite side. And of course, that would switch if we were talking about C. We would switch that in that place. Now, there are three ways that we have to, ratios that we have to remember. The first is sine, and sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now there's a few different ways that people go about remembering this. The one way to remember this is Tom's old aunt sat on her cat and, as I like to say, hollered. Hollered. Ghetto language. Okay, so what is that? Tom's old aunt sat on her cat and hollered. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's one way. Tom's old aunt sat on her cat and hollered. Or another way you'll see people do it is they'll write it out like this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And sometimes you'll see it SOHCAHTOA. 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 You know, if you want to put a little accent in it or something. SOHCAHTOA. So, Tom's old aunt sat on her cat and hollered, or SOHCAHTOA. Whatever works for you, all right? And remembering those. So, write the trigonometric ratios for each of the following. And when we see trigonometric ratios, we're thinking sine, cosine, and tangent. So the first thing I'm going to do on this is I'm just going to rewrite what those are. Tom's old aunt sat on her cat and hollered. I want to bring it into the space that I'm working. And I notice that this one is referring to angle A. So now, the first thing you want to do is you want to identify your hypotenuse, your opposite, and your adjacent. So let's start with our right angle. Across from there, that's the hypotenuse. I'm going to abbreviate it, HYP. The other side that the angle touches is the adjacent. I'm going to abbreviate that, ADJ. And then across from the angle, you get your opposite side. So now we're going to write those out. So the first one here is the tangent of A. And you can abbreviate that. TAN of A is, well, it's the opposite over the hypotenuse. The opposite is 4. The hypotenuse is 5. Next up is the sine. We abbreviate it SIN. You don't say the sin of A, it's the sine of A, but that's how we abbreviate this in trigonometry. Okay, even though it looks like sin A, the way that you say that is sine A. So the sine is the opposite over the hypotenuse. So again, we look at our diagram. What's the opposite? That is 4. And the hypotenuse is 5. And look at me. I totally messed up here with tangent. Oh my goodness. Let's go back and fix that. Okay. I was thinking sine. Tangent is the opposite over adjacent. Hopefully you caught that. The opposite is 4. The adjacent is 3. Now the sine, that is opposite over hypotenuse. And the last one, the cosine, which you abbreviate COS of A, cosine is the adjacent cosine. I'll go back up to here and I just look, okay, there's cosine. It's the adjacent 3 over the hypotenuse. You know, so sometimes it can be really simple to make a mistake. So we want to be careful about that. All right, well, let's try number 2 now. And, you know, here we are again, a new question. So I want to bring into the space these things. So Tom's old aunt sat on her cat, and hello. All right, I just want them right there. I want to be able to see that. And then I want to identify what those sides are. Well, notice here that we're talking about angle C. Start with your hypotenuse. Okay? It's okay to abbreviate that, HYP. The other side that the angle touches, the side next to it, is the adjacent. So that's 5. And then across from C, that is going to be our opposite side. So in this example, let's do first the tangent of angle C is, and you're going to see that the tangent of angle C is the opposite over the adjacent. I'm coming back up here and I'm referencing this. I don't want to make a mistake like I did last time. So that's 12 over 5. Next we have the sine. So sin of C is, sine is the opposite over the hypotenuse. So the opposite is 12. Our hypotenuse is x. Last, we have the cosine of C, and the cosine of C is the adjacent over the hypotenuse, which is going to be 5 over x. And you can notice that sine and cosine are always going to have the same denominator. All right, well, what I'd like you to do is push pause and try 3 and 4, and then we'll come back and we'll give you the answers to those. Okay, we're back, and here are your ratios for number 3 and 4. You can see them there. Tangent of A is x over 8. Sine of A is x over 17. Cosine is 8 over 17. 4. Tangent of A is 8 over x. Sine is 8 over 10. And the cosine of A is x over 10. All right, so notice I labeled them with those, and doing those things is important. All right, so use the following diagram to find these different values. So now we're just presenting this here in some different ways, but what's going to happen now is we're going to change the angle. So again, remember, it depends on the angle. So here's what I'm going to do. I'm going to do it in 2 colors. If we're talking about angle A, now the hypotenuse is always going to be the same. That's not going to change. But the adjacent side, remember, your angle touches the hypotenuse and the adjacent. So the word next to, it's right next to that. And then that would leave this side here as our opposite. Well, but what if I'm talking about angle B? Now again, the hypotenuse is going to be the same, but now B touches side BD. So in red, I'm going to write that's the adjacent. If we're talking about red or angle B, that's the adjacent side. Now this one is the opposite side. So again, this is really going to depend on which angle we're talking about. So to help illustrate that to you, if we're talking about angle A, I'm going to do it in a blue ink, and we're talking about angle B, I'm going to do it in red ink. Now, I don't have my my info from the other side, so it's a new question, it's a new space. I want to bring in Tom's old aunt sat on her cat and hello. Okay, I'm just bringing that into the space. And number 1, sine of A. Okay, A sine is, I look up here, opposite over hypotenuse. So I'm in blue, so it's 8 over 17. Number 6, the sine of B. Oh, I'm going to switch to red. What do we have here? Sine, it's still opposite over hypotenuse, but in this one, the opposite is 15 over 17. So it really depends on the angle that you're talking about. Now the tangent of A, whoops, I got to use blue for A. Okay, What's tangent? I look up here. Tangent is opposite over adjacent. So I go to A. Opposite of A is 8. Adjacent is 15. So 8 over 15. Cosine of B. I'm going to switch to red because B is my red angle. So I'm looking for cosine. Cosine is adjacent over hypotenuse. So my adjacent to B is 8. My hypotenuse is 17. Okay. Now number 9, when we name it this way, look at that middle letter. That's your vertex. So this is angle B. The cosine of B is the adjacent over the hypotenuse. That's 8 over 17. That's just another way of naming it. And then our last one, tangent. Oh, what's tangent? Tangent is opposite over adjacent. So again, B is your middle letter here. So that equals 15 over 8, the opposite over the adjacent. Hopefully I got those colors right in doing that. But it's really important to recognize that the hypotenuse will always be the same, but your opposite and your adjacent depend on the angle. Okay, and it changes in this example. It's a great example of, is it angle A or is it angle B? So in this case here, we're going to see some different things. Find the missing side. State the trigonometric ratios for sine, cosine, and tangent. Okay, now find the missing side. How are we going to do that? Well, here's where we need to remember what we had done before. What do we know about this triangle? It's a right triangle, and we know two sides. And so when you know two sides, we need to think the Pythagorean theorem, which is the hypotenuse squared equals the sum of the squares of the legs. Okay, so what's our hypotenuse? Here's our hypotenuse. It's 25. So 25 squared equals y squared plus 20 squared. Okay, so 25 squared is 625 equals y squared plus 20 squared is 400. If we subtract 400 from both sides, we're going to have 625 minus 400 is 225 equals y squared. And when we take the square root of that value, the square root of 225 is a perfect square, and that is 15. So our side is 15. And then state the trigonometric ratios. Now, what it tells us here is it's for this angle. It doesn't really say that clearly, but let's call it angle A with a capital letter just to get those. And so here again, we've already got our hypotenuse. Again, the other side that it touches is the adjacent, leaving us left with the opposite. So the tangent of A, tangent is Tom's old aunt, 15 over 20. Okay, sine of A, sat on her, that's going to be 15 over 25. Cosine, cat, and hollered, adjacent over hypotenuse, 20 over 25. And of course we could reduce all of those fractions. I'm not going to do that right now, but we could do that. So recognize that sometimes you have to use the Pythagorean theorem. Okay, Pythagorean theorem to find that missing side theorem. Okay, now I want to look down. We'll skip number 12 here. I want to look down. How do we do this on our calculator? Now, I apologize. I don't have the ability right now to show you the calculator on the screen. But the big key here when you're doing this on the calculator is to get the mode right. So when your mode button on your graphing calculator, what we want to make sure that we set this to is we want to make sure that we have degrees. So when you click on mode, you'll see an option and you'll have radians and degrees. And you're going to go ahead and click on degrees. So I'm just going to do a few of these. We want to round it to the nearest 10 thousandths. So once I go to my calculator, I make sure my mode is in degrees. All we do is there's going to be an SIN button, sine, put in 5, hit enter, and you're going to get 0.087155747. Okay, nearest 10 thousandths. So we have our tenths place, our hundredths, our thousandths, our 10 thousandths. We want to round to that one. Look to the one place next to the right of it. It's a 5. That means we're going to bump that 1 up to a 2. So 0.0872. Cosine of 45. Again, on our calculator, cos 45, 0.707106. 10 thousandths, that's 4 decimal places. I look at it, I got a 1. To the right, it's a 0. So we keep that as a 1. All right. And then the last one, tangent of 80, is 5.671281. All right, so 1, 2, 3, 4. And we want to round here. Tenths, hundredths, thousandths, 10 thousandths. What are we going to do? We're going to round that up. 6713. All right, so you'll see that tangent is the only one that will have values bigger than 1. I'm not going to do the other ones. I think you can get that easily, and we'll be doing some practice with that in class. All right, here's the movie trivia question for you. All right, in what movie did they say, put on your booties because it's cold outside? That's right, camp campers, it is cold outside. What do you think this is? Miami Beach? Okay, write that down. And if you write that down, we'll have a little something for you as a little bonus prize. All right, goodbye.